All right, guys, on number 2, what we're looking at here is this is going to be like a solids of revolution problem. It's a little bit different, and so we'll just jump right into it and take a look at what we've got going on number 2. So we've got these two graphs right here, and it says the function f is defined by, and it gives us what f of x is. So far, so good. The function g is continuous and decreasing for 0 to 3, with g of 3 is equal to 0. Now, you'll notice that it doesn't tell us what g of x is, and that's going to come back to in a lot of ways to make this problem easier in some ways but more difficult in others. So I look at this and I'm like, okay, I've got the figure above on the left shows the graph of f of g in the regions r and s. Okay, and then it says r is the region bounded by the graph of g and the x and y axis. So this area down here is r. Then it says region R has an area, and it's kind of weird that it gives it to us, but it says region R has an area of 3.4125. So that is that area right there. Then it says S is the region bounded by the y-axis and the graphs of f and g, but it doesn't tell us what that area is. The figure above on the right shows the graphs of y equals g of x squared, really weird, and the region T. Then it tells us that this area T has an area of 5.32021. Again, very strange that they give us those, different than a lot of the other problems we've looked at. Well, letter A says find the region of S. So if we look at this, we're like, okay, that's going to be the integral from 0 to 3 of f of x minus g of x. The problem here is I know what f of x is, but g of x, I don't know what it is. So what we kind of have to do in this problem is say, oh, all right, I'm going to find the area of f of x. Then it tells me in the problem that the area of g of x is that 3.241. So I find the area of f of x, and then I subtract off that 3.241. And when I do that, I get 4.919 or 4.920 is actually what it rounds to. So that's your answer for letter A. Again, the trick here is knowing that the area between the graph of g and the x-axis from 0 to 3 is that 3.241. Now, letter B I actually thought was very difficult. Letter B says, find the volume of the solid generated revolved around the line y equals negative 3. So we're going to revolve around this magical line down here at y equals negative 3. I'm going to revolve around that, so that's pi times the integral from a to b. That's, from 0 to 3, that doesn't change, of the function further away, f of x minus negative 3. So I'm just going to put plus 3 squared minus g of x plus 3 squared. So I've got my setup, and I'm like, okay, that's not that big of a deal. Then you realize something. I can find this entire first part right here, but the second part, because I don't know what g of x is, let alone what g of x plus 3 squared is, that is going to be an issue. So what we have to do in this problem is we actually have to FOIL out g of x plus 3 times g of x plus 3. When I do that, what I get is I get g of x squared plus 6g of x plus 9. Now the reason why I do that is I say, okay, I know how to find the integral of this first part. If I can subtract off the integral of the second part and then multiply my whole answer by pi, I can do that. Furthermore, if I just give all of these integrals from 0 to 3 to each of the terms in here, so I've got 0 to 3 there, 0 to 3 there, and 0 to 3 from 9, of just 9, and all of those have a dx on them, it tells me the integral from 0 to 3 of g of x squared, 5.32021. If I pull the 6 out in front of this, I know the area as well from 0 to 3 of g of x. That is 3.24125. And I'm just going to multiply that by 6, and that'll tell me that. And then if I do the integral from 0 to 3 of 9 on my calculator, or just do it however, I find out that that's 27. So I can add all three of those together and then subtract them from this integral that we have right here, then multiply all of it by pi, and when you do that, you get 156.264, or 263, either one of them, which is the answer to letter B. And again, I thought that one was very difficult. Letter C says, we're back to S again, okay, and it's the base of a solid. For this solid, each cross-section perpendicular is a rectangle, okay? So remember, if it's a cross-section, we do the integral from A to B of the area of the cross-section shape times dx. Well, in this problem, the area is a rectangle, so that's base times height. And it says the height is equal to 7 times the base. So really what I have here is my area is equal to base times 7 times base, or if you wanted to simplify that, base squared times 7. So I've got the integral from a to b of 7 times, my base on every one of these is going to run from f of x to g of x. So if I want to find that distance, it's just going to be f of x minus g of x. And then we're going to square that. And we don't have to solve it. That'd be, and our a and b in this case are 0 to 3. And so we're all done. You just have to have that written as your answer on letter C. Again, a little bit more complicated in some places, but hopefully all of that made sense. If you have any questions about that one, please let me know.